Alright, okay, a student investigates the kinetics of the reaction by using a spectrometer. So the spectrometer actually measures the concentration iodine by measuring the absorbance. So the absorbance actually tells you the concentration iodine. Alright, so the time taken for the absorbance of the reaction to reach a fixed value is measured over a range of hydrogen peroxide concentration. So the table looks like that. You vary the concentration of H2O2. So you do this experiment a few times. Alright, you vary the concentration of H2O2 and you measure the time, alright? And this time is the time taken for a fixed, this is important, a fixed value for the absorbance of the mixture to reach a fixed value. Okay, what it really means is you are actually finding the time taken for a fixed amount of iodine to be formed. A fixed amount of iodine to be formed. So the rate actually is supposed to be change in concentration iodine, which is a product, over change in time. So you're actually measuring the time taken for a fixed amount of iodine to be formed, which means I take the numerator here to be a constant. Alright, so now you can see the rate will be proportional to 1 over t, right? So the numerator is constant, so it's just time dependent. So which means you need to have one more column that puts 1 over t, and this is actually your, I'll call it relative rate. Okay, but it's just still rate. So what you need to do is you're supposed to plot a graph of rate versus concentration of H2O2 in order to find the order of the reaction with respect to H2O2. So since the question says is first order, respect to H2O2 is first order, it looks like the answer would be this, because since rate equals to K, H2O2, so rate versus this is proportional rate, and concentration H2O2 is proportional, and this is rate. Okay, and yeah, it's proportional. Alright, so the answer is D.